action. And scene. Make sure you can see me. Alright. Thrown up and down problems. I can watch this later and see how boring I am.
Don't make any corny jokes.
Alright, examine 3 different positions of the object. So we're going to look at when the ball leaves my hand, at the max height, and then when it returns to my hand again. It's going to be a YouTube sensation. Alright. Not. Alright, first position. This is my little hand. Look at my little hand here. And here's my little tennis ball going up. And we have...
Ew.
What do we see? I'm not an art teacher. So the ball leaves our hand. What's going up? What's going up in terms of our variables here? What's going up? If I throw something up. The velocity, yes, thank you, Labika. So my V initial in the Y is positive. Alright, our initial, this is new. This is new, because our V initial was always what? 0 when we did our free fall problems, right? So this is new, it's not going to be 0 now. What about the acceleration? As it's leaving my hand, what's the acceleration?
0.
Gravity disappeared
9.8.
all of a sudden.
9.8 meters per second.
Negative 9.8 meters per second squared. This is acting in what direction?
Down.
Downward. So that's, again, my sign convention. Up is positive, down is negative. Acceleration x that way, it's negative 9.8. Alright, now let's look at the ball. I threw it up. The ball's up here. My little hand's down here still. My fingers got cut off. I don't know. They're smaller. Let's talk about the velocity up here. When the ball reaches max height, what's the velocity? 0. Momentarily it stops. So your Vy at the top at max height is 0. We like that. Things cancel out. What's the acceleration at this point when the ball stops?
0.
Conrad? Still negative 9.8. That's a big misconception. A lot of the questions come up. What is the acceleration after the ball reaches max height? And you're like, ah, it's 0. No, it's not. The acceleration is still, it's still negative 9.8. Don't try that at home, children. Don't try that at home.
How'd you throw it out?
I'll tell you off the record.
Oh.
Okay. 3. Alright, so the ball is in my hand. That's 3 different hands. I don't know what's going on here. The ball is about to strike my hand. This is your V final Y. What does that equal? What does that equal? It doesn't equal 0. Well, actually, when it stops, it only equals 0. So,
It's like negative.
yes, it is negative. It actually equals negative V initial Y. Who can explain that to me? What does that mean? That the V final Y is equal to negative V initial Y. You know.
Like the velocity at which, like the ball, like when it was when it left your hand and when it comes back to your hand is the same.
Slow clap. What's a slow clap? What's a slow clap? Unit is correct.
I didn't even hear what you said.
If the ball leaves my hand at 10 meters per second, right? Reaches max height at 0. When it hits my hand, it's negative 10 meters per second. So whatever the initial velocity is, whenever it hits your hand, it's just a negative of that. Because it's going in a different what? Direction. Initially it's positive. My sign convention up is positive, coming back down. So there's nice symmetry to this problem. We're going to like that. So, what is the A here right before it hits my hand? Yes, thank you. Negative 9.8 meters per second squared. We like that. Okay? So let's summarize this now with some words. On the way up, the object is speeding up or slowing down?
Speeding up.
No.
Slowing down. Thank you. Slowing down. Why is it slowing down? What's acting on it? Gravity is accelerating it downwards. So as I'm going up, it's slowing down. At the top of the flight, V equals?
0.
0. And half of the what has passed? I heard it.
Distance.
Time. We'll talk about distance in a second. So if it takes 2 seconds to get to max height, how long does it take to get back down?
2
2 seconds. There's nice symmetry here. On the way down, the object is speeding up. It's like our free fall. Essentially, it is a free fall, right? The ball goes up, it stops at that max height, v initial 0, right? If you look at the second half of the problem, it's a free fall problem, right? Second half. That's why we do free fall first. The whole time, A equals negative G equals negative 9.8 meters per second squared. Just don't make that mistake. That happens a lot. The question says at max height, what's the acceleration? And I hear, oh, it's 0. It's not 0. It's always negative 9.8. So the blank up is equal to the blank down. I didn't put that word there. What is it? Not the velocity. The distance, right? So the distance up, if it goes up 5 meters, it's going to come back down 5 meters. So distance up is equal to the distance down. Extend page. And the blank and blank speeds are equal. The blank and the blank speeds are equal. Fill that. Initial and final speeds are equal. Why didn't I say velocities? Why didn't I say the initial and final velocities are equal?
Because the yeah.
The direction's different. They're not the same. The direction will be, they're opposite directions, okay? So speed is a scalar, it's just the magnitude, and that's why those are equal. Yes, we good?
Yeah.
Okay, let's look at the X. A ref tosses a coin up with an initial speed of 6 meters per second. In the absence of air resistance, how high does the coin go above its release point? Okay, so let's, number one, look at some of our knowns and unknowns. My V initial and the Y equals. What does it equal? I'm even going to put here 6 plus 6.0 meters per second. Why did I make an emphasis on the plus here? Because it's doing what?
Because it will be negative.
Well, it's going to be, maybe. We don't know. It is, but right now, where's it going?
Up.
It's going up. Our sign convention. Left my hand is going up, that's why it's positive. What else do I know? What else do I know? That's all I know?
A.
Well, I know my A equals negative 9.8 meters per second squared. What am I looking for? Yes, we're looking for how high up it goes. So I'll say my dy equals question mark. Now, what's the other thing we know? This problem, it's implicit. It's not stated directly, but you have to pull it from the problem.
Is it V final?
It's V final. What's my V final? What is it?
Negative.
We're looking for the max height, how high it goes. It's 0. V final Y is 0. We're just looking at how high it goes. So initially it's in my hand at 6. At the max height, it stops, and your V final is 0. Yes, Jenna?
You lost my tennis court lab.
Oh, it's my fault?
Yeah, I gave it to you.
Alright, we'll figure it out. We're taping.
Did you show them the video yet?
We're making one!
Oh, never mind.
Okay, I'll look for it. Note this up. Really? Really? We should put a sign up on the air.
No
Alright,
stress.
so what equation am I going to use here? V final, V initial, A, D.
V final squared equals V initial squared.
Yes. So V final Y squared equals V initial squared. So the Y in there plus 2AD. V final Y is 0 equals 6.00 meters per second squared plus 2 negative 9.8 meters per second squared dy. Put the dy in there. Okay, we like that. 0 equals 36 minus 19.6 dy. Take the 19.6 over to the other side. 19.6 dy equals 36. Divide both sides by 19.6. dy equals, alright, let's say 1.84. Positive or negative, Una? Positive. Why does that make sense? Tell me why that makes sense, that it came out positive. Well, then mathematically, yeah, but why does that make sense?
Distance going up.
I saw how high the coin was going up. If my sign convention said this was 0, I'm looking at how high does the coin go. It came out positive. We like that. Always see if your answers make sense.
Wait, how did you get 0 for
Watch the ball. Pretend this is the coin. When it gets to the max height up there, what's the velocity?
6
It's 6 when it leaves my hand. Look up. When it reaches the max height, it's really for a split second, but what is it? 0. Do you see how it stops? It has to stop because then it comes back down. That's why. We're looking at half the problem, from when it leaves my hand to the top. Not the whole thing. We'll talk about that. So using the x, how do you find how long an object's in the air? So what is the total time the coin is in the air before it returns to its release point? Can we look at this half of the problem? Well, how can we look at half the problem? What can we find first? The time what? To reach maximum height. Okay, can we do that? Let's do that. So, and then once we find that, what do we do with that time? Double it. Just multiply by 2. So, well, let's just state that. The time to go up is equal to the time down. Okay, so we know we're going to find half of the time here. So, which are we looking for here? Alright, so t equals question mark. I have a v final y equal to 0. I have a v initial y equal to 6.00 meters per second. And what else do I have? I have a equals negative 9.8 meters per second squared. So, what equation can I use? What equation can I use? There's different ways to approach it. You could use either equation. So, if we use the, well, did you say D? Who said D? You know. Say that again?
Because you found D, so you just substitute that into that equation.
Okay. With that equation, though, you're dealing with squares, right? 1/2 at squared, and you have the t. So do we have a simpler equation that's maybe easier? Let's, yeah, that one's probably easier. So let's say VF final equals,
Wait, well, aren't you looking for time? So why don't you use that? Oh.
you have the t. In the d, it's VIT plus 1/2 at squared, you involve with quadratic, right?
Alright.
Which we can do. We'll talk about that too. But let's try to go easier. So 0 equals 6.0 meters per second plus negative 9.8 meters per second squared times t. Bring that over, 9.8 t equals 6. Divide by 9.8, divide by 9.8. T equals, we got about 0.612 seconds. Is that my answer? Is that my answer? No, that's just the time it took to go from my hand to max height. So to get total time, extend page. T total equals 0.612 times 2. Okay, and that rounds to about 1.22 seconds. Now, I challenge you. You can make it, I'll make it like a homework bonus maybe. Solve for the time using, I don't know if I'll give you the whole clue. Do it without doubling the time. See if you can figure out how to solve for the time with one step. One step. Not having to double it, just doing it one time. Okay, try that. I'll just throw that challenge out to you.
This problem.
Yeah, with the same problem to solve for the time without having to double it. Shall I give you a clue?
Yeah.
Don't say anything because you're going to give it away. The clue is displacement. Use like the concept of displacement. Yuna, don't say anything. Figure it out on your own. I think. Do you know it already?
I don't know if I'm right though.
Don't tell anyone.
I'll
You
just
can.
gonna double
I
Am I right?
don't know, but I don't want anyone to give you any clues. Just try it on your own. Okay. All right. So that's the total time. All right. Flip it over. Flip it over. Practice problem. I want you guys to do this with your little partners there on your own. A baseball pitcher throws a baseball straight up with an initial velocity of 27. He catches the ball in the glove the same way he threw it. So, show all your work. How long does it take the ball to reach the highest point? How high does the ball rise above its release point? How long is the ball in the air for? And what is the velocity of the ball when it strikes his glove? Okay? And go. You can stop that. YouTube